Imagine you are an engineer designing analog circuits. What if you no longer had to manually piece together each component? In this work, our goal is to automate the creation of complete analog circuit schematics from scratch or by completing partial designs. Our model works using two separate parts, a node prediction model that suggests the next component and an edge prediction model that determines how to connect it based on real and synthetic circuit data. We represent circuits as graphs, where components are nodes and wires are edges. For this demonstration, we begin with an incomplete circuit containing only a single NPN MOSFET. This partial circuit needs to be completed. Here's where our transformer-based model comes in. It analyzes the existing components and connections and predicts what should be added next. The model takes in the current list of components and their adjacency matrices and predicts one component at a time until it identifies there are enough components to make a complete electronic circuit. Once all components are generated, the next step is connection prediction for each pin of each component. For clarity, let's demonstrate this with a smaller component set. Our edge prediction model calculates the probability of connections between each pair of components. Higher values means more likely and more functionally varied connections. By applying a threshold to this probability matrix and refining based on domain-specific rules, we generate the final schematic. This ensures increased accuracy and circuit validity. If you go through the dataset, this generated circuit is new but functionally similar to circuits in the dataset which the model trains on. In our experiments, we compared two edge prediction models, a cyclic and a non-cyclic transformer. The non-cyclic model achieved higher accuracy and F1 score while the cyclic model showed better precision. For the node prediction task, we observed that accuracy varied depending on the number of components already present. The model performed better when it had around 10 or more components to work with. This demonstration shows how machine learning can accelerate analog circuit design by automatically predicting both the components and their connections. With this approach, circuit design moves from manual to intelligent and streamlined. We thank the Generative AI Hackathon team for this opportunity, guidance of Daswin D. Silva and Lakshitha and mentorship of Dr. Tharindu Bandaragoda. We would also like to acknowledge IEEE Industrial Electronics Society for the Students and Young Professionals Paper Assistance Program.